Hello chaps and chapettes. Well, term is finally over for me here right now. So here I am in my holiday get-up instead of my suit and tie. And what I'm going to do now is a quick tip on Kirchhoff's law, or Kirchhoff's, I've really never learned how to pronounce it properly, law and parallel circuits. And showing you how current changes in parallel circuits and why this can cause some problems. And also, understand the implications for potential dividers on here as well. So by the end of this video, you should know those things, understand those things. Let's jump straight into it and show you the problem at hand. Right, so this is a very, very simple circuit. And I don't think I've ever seen a 1 ohm light bulb in my life, but we're going to do some easy maths on this one. So we're going to think about the problem of Kirchhoff's law, or Kirchhoff's law, the current laws, in parallel circuits here. And first of all, we need to establish what is the current flowing through this lamp or light bulb. And that's going to be relatively straightforward. We've got first equation, V equals I R. Okay. And then we know our voltage, so we need to do a quick rearrangement. I is equal to V over R. Going to run out of space here. And that's going to equal to 6 over 1. And then we're going to get our calculator out on this one, and we're not going to bother because this is quite an easy one. So that should be 6 amps. Okay, nice and straightforward. So that's how much current is going through this light bulb right now. So then what we're going to do is we're going to add another light bulb, one which is exactly the same. Okay, so we have exactly the same light bulb now, and we have 6 amps flowing through here. And now, because this is a parallel circuit, we have the exact same voltage dropping across this thing. So 6 volts needs to drop across this thing. This is still 1 ohm light bulb. And so we should have a current of 6 amps. So let's just show that now using a lovely green pen. 6 amps. And 6 amps. Now, Kirchhoff's law says that when you get a branching point, currents will add to each other. So on this side, we're going to have 12 amps. And of course, we should have 12 amps on this side as well. Now, here's the thing. If we add another light bulb on there, which is exactly the same, we get the exact same current flowing through that one, because that's still going to be 6 volts dropped across there. It's still going to be 1 ohm, so we still have 6 amps, which means that this now goes up to 18 amps, and you can start to see a problem. The more light bulbs we add to our circuit, the more and more currents we're going to draw off of it. Now, if you're using something like this, a power pack in a circuit, not going to be a problem, because this thing has a nice little trip button, which is going to trip if the current gets too great, so you can't get into too much trouble. However, if you're using one of these things, a cell or a battery pack, that's when problems can occur, because you start to draw too much current, things get too hot, particularly in this thing, and well, catches fire, maybe pops open, something like that. So that's a problem with Kirchhoff's law and parallel circuits. Now, you've experienced this in your house when you've added too many appliances to like a multi-plug, and you've turned them all on, and as soon as you turn them all on, the house goes black as you trip your circuit breakers, which I just happen to have around here. So basically, instead of plugging in light bulbs, you plug in like a toaster, vacuum cleaner, fridge, freezer, all those kind of things. You plug in one last thing, your hairdryer, and turn it on, and suddenly you're drawing too much current, and your circuit breaker is going to trip. That's why that's there. Because most households run off of parallel circuits for main circuitry. Basically to keep the same voltage across the entire circuit, or across the household circuit. So, there we go. That's the reason why you have circuit breakers, and that's the reason why your lights will go out. There is one more problem with this one though, when you're looking at potential dividers. Now, I was trying to set up a potential divider using a light bulb and this thing here, and there was a big problem with it. because this needs to be in parallel with the LDR there. Now the resistance of this light bulb is much lower compared to the resistance of the LDR and also the other resistor. And that meant even though the voltage was the same across each thing, the light bulb and also the LDR, most of the current was actually flowing through this thing here. We weren't actually getting much current going through this one. And that was a big problem with it. So this is something you need to consider if you're doing A-level electronics. You're going to need to consider the current flowing through your parallel circuits as well as the voltage being dropped across there. Thinking about Kirchhoff's law all the time. And there we go.